Okay, hi guys, so let's start. So we have first the unit of molar mass is gram per mole. Okay, so we can just define that 1 mole of X atoms is gram atomic mass. Okay, 1 mole of X molecules is gram molecular mass, and 1 mole of ionic compound X is gram formula mass. Okay, so numerically we can say that atomic mass is equal to gram atomic mass, although unit is different. Okay, so next let's define what is number of moles, or how is number of moles calculated rather. Okay, so number of moles is nothing but given mass of a substance. So we can directly say that given mass upon molar mass is the number of moles of a substance. Okay, now let's actually do a question on it. So you have to calculate the number of electrons in 9 gram of Al3 plus. Okay, so aluminium will contain 13 electrons and Al plus 3 will contain 10 electrons. Okay, so now as you can see that molar mass of aluminium would be 27 grams. Okay, now number of moles in 9 grams of aluminium would be 9 divided by 27, which is 1 by 3. Okay, so how many moles of electrons would be there? Obviously 10 by 3 moles of electrons. Okay, and so number of electrons would be 10 by 3 into moles is the quantity of 6 into 10 to the power 23, or rather 1 mole is equals to 6 into 10 to the power 23 entities, and electron was one of the entities. So number of electrons would be 2 into 10 to the power 24 electrons. This would be the answer. Okay, let's look at another example. So we have to calculate total number of atoms in 500 gram of Ca3PO4 whole twice. Okay, so you can calculate the molar mass of Ca3PO4 whole twice. So molar mass would come out to be 310 okay grams. So number of moles in 500 gram of Ca3PO4 whole twice would be 500 divided by 310. Okay, this is the number of moles. Okay, hence total number of atoms would be number of moles multiplied by the Avogadro number. Okay, so it will contain this number of atoms. So if you simplify it, so obviously it will cancel it out, and 50 into 6, or rather for calculating total number of atoms, so this is the total number of molecules. Okay, I beg your pardon, I wrote it atoms, but this is the total number of molecules of Ca3PO4 whole twice. Total number of molecules of Ca3 PO4 whole twice. Okay, molecules. So it will come out to be, you can calculate this number. Okay, so the main point is you have to calculate total number of atoms. So total atoms in a molecule, or rather a molecule of Ca3PO4 whole twice would be 3 atoms of carbon or calcium plus 2 atoms of phosphorus plus 8 atoms of oxygen. So it would come out to be 13 atoms. Okay, so total, hence from equation 1, this was equation 1, total number of atoms would be total number of molecules multiplied by 13. Okay, so it would be 50 divided by 31 into Na multiplied by 13. So it will come out to be, answer would be 650 divided by 31 into Avogadro number would be the answer. This is the total amount of atoms in 500 grams of molecule, which is Ca3PO4 whole twice. Okay, so now let's move in the definition of ideal gas. Okay, so ideal gas is, it is a gas that obeys PV equals to nRT equation. So it obeys PV equals to nRT. Okay, where P is the pressure, V is volume of vessel or gas in which the gas is kept, volume of vessel or gas, N is number of moles of that gas, R is gas constant, okay, and T is temperature. Okay, so just to define the standard things, like 1 atm or atmospheric pressure is equals to 760 milligram of mercury, okay, which is also known as 760 torr. Okay, and 1 bar equals to 101,325 Pascal. Okay, and which is equals to rather atmospheric pressure, and this is equals to 10 to the power 5 Pascal. Okay, hence you can calculate that, rather this is so this is actually I wrote this previously was right only, it is Pascal, so I'm just rounding it off here, equals to so this 1 bar equals to 101,325 Pascal, which is 1 atom, atm, not atom, 1 atmospheric pressure. So just to convert that, you can now convert or have the relationship between 1 bar and 1 atm. Okay, now let's see some SI units of pressure, which is atm. SI unit of volume is liter. SI unit of gas constant is atm liter divided by mole Kelvin. Okay, for temperature it's Kelvin, and for N is mole. And we can calculate that the gas constant is 0.082 mole liter upon, or rather atm liter divided by mole Kelvin. Okay, So here we can actually also write it like P equals to N divided by V nRT, or rather RT. Okay, now what actually will happen here is N is nothing but given mass upon molecular mass. N is nothing but given mass divided by molar mass divided by V. Okay, and we can actually write that given mass upon volume would be density. Okay, which will represent by rho. Okay, rho RT divided by m, which is molar mass. So we can also write it in terms of rho or density. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing, or rather we'll be continuing our chapter. Okay, so till then, good luck and goodbye.